All right. So, as a philosopher, I'm sure you've spent plenty of time thinking about knowledge and belief.
Right. Yeah.
But have you ever considered what happens when they're not static? It's like not just these things in our heads,
Yeah.
but when they actually change, when we talk to each other or interact, like
Mhm.
how our knowledge or beliefs are actually shaped by those interactions.
Yeah, that's a really interesting way to put it.
Okay, so let's dive into that. Today we're going deep into dynamic epistemic logic,
Okay.
or DEL. It's kind of like Dell,
Yeah.
the computers.
Right.
But for logic.
I like that.
So if you're into formal methods, which as a philosopher, I'm guessing you might be.
To some extent, yeah.
This is going to be really fascinating. DEL is a really active area of logic that basically looks at how our models of the world change when we learn new things.
And what's really exciting is how broadly applicable this approach is. As a philosopher, you'll see the connections to formal and social epistemology immediately, how we come to know things both individually and as a group. But it also goes deeper into epistemic and doxastic logic, the logic of knowledge and belief themselves.
Okay.
And it's crucial for understanding belief revision, which is something we'll talk about, where our existing beliefs have to kind of adapt.
Yeah.
And even beyond philosophy, DEL has applications in things like multi-agent systems, distributed systems,
Right.
even AI defeasible reasoning, non-monotonic reasoning, which is how we draw conclusions that can be overturned later, and even epistemic game theory, how strategic knowledge influences our interactions. So it really shows how fundamental these information dynamics are across so many different fields.
It's really far-reaching, and it's not all abstract theorizing either. Like, DEL gives us a formal way to look at some really mind-bending puzzles.
Oh, yeah.
Like Cheryl's Birthday, have you heard of that one?
Of course, yeah.
The Money Children puzzle.
Another classic.
The sum and least common multiple puzzle. These are all brain teasers that really get you thinking.
Yeah.
And what's really cool is that they all hinge on how the agent's knowledge evolves through their interactions.
That's the key.
And DEL provides this really precise framework to break these scenarios down step by step and see exactly how new knowledge emerges.
Yeah.
Take the Muddy Children puzzle, for example.
Mm-hmm.
Just the father asking, does anyone know if they have mud on their forehead?
Mm-hmm.
Sets off this whole chain of logical deductions
Right.
as the children observe each other's reactions in silence.
Mm.
And DEL lets us formalize how that shared lack of a yes answer actually becomes a piece of knowledge that leads them to the solution.
Right. It's fascinating how that works.
Exactly. And the core idea of DEL is actually quite elegant.
Yeah.
It takes the logical languages we already use, like modal logics,
Yeah.
that deal with necessity, possibility, what agents know or believe,
Yeah.
and it adds these new tools, these modalities. And they don't just describe states of knowledge like agent and knows P.
Right.
They let us represent the actions that change those states so we can actually say things like, after announcing P publicly,
Right.
and then analyze how that changes what everyone knows.
Exactly. It's like modeling the impact of communication on knowledge.
It's like going from a snapshot of what we know to a whole movie of how that knowledge unfolds and changes over time through interaction.
It is a much more dynamic picture.
Exactly.
Yeah.
So today we're going to explore how logic can capture this evolution of knowledge and belief in these dynamic situations.
Right.
And we'll start with the most basic kind of model-changing operation,
Mm-hmm.
public communication,
Makes sense.
where something is said out loud and everyone hears it.
Yeah. And I think, as a philosopher, you'll appreciate that this is a really natural extension of more traditional static approaches to knowledge.
Yeah.
DEL just gives us the tools to be more precise and rigorous about it.
So let's jump into public communication and its logic.
All right.
And the key framework here is public announcement logic, or PAL.
Okay.
And what's more basic for a philosopher than a public announcement? It's when someone says something and everyone hears it. Simple as that.
Yeah, absolutely.
So PL formalizes that when a statement or a formula S is publicly announced, it's like a filter on our understanding of the world. It restricts the possibilities we consider to only those where F is true.
Right. It's an update to our shared model of reality.
Exactly.
Yeah.
And there's a handy notation for it,
Yeah.
FG, which means after F is announced, and only if it was true to begin with, G becomes true.
It's all about the effects of the announcement.
Exactly. And within this framework, we can start exploring some really interesting concepts that come up when we talk about groups.
Oh, yeah.
Like group knowledge, PAL, gives us the tools to define and reason about common knowledge,
Right.
which we write as CF. And common knowledge isn't just that everyone knows F individually.
No.
It's stronger. It means that everyone knows F and everyone knows it. Everyone knows S and everyone knows it. Everyone knows F and so on infinitely.
It's a much deeper level of shared understanding.
It is. And it's crucial for things like coordination, social interaction, even shared meaning in language.
Absolutely.
And then we have distributed knowledge,
Right.
which is different from common knowledge. It's not about any one person knowing something.
Mm.
It's about what the group would know if they pooled all their individual knowledge.
Exactly. Like imagine one person knows half a code and another knows the other half.
Right.
Neither knows the full code alone.
Right.
But together they have that distributed knowledge.
They do. So PL lets us formalize how public announcements affect not just individual knowledge, but also these group knowledge concepts.
And it's amazing how it can handle that.
It is. And one thing about PL that's always fascinating to me from a philosophical perspective is more sentences.
Oh, yeah, they're tricky.
They sound so paradoxical.
They are. A more sentence can be true, but as soon as someone believes it, it becomes false.
Wow.
Like, P is true, but Agent A doesn't believe it.
Okay.
If Agent A believes that sentence, the second part becomes false.
Right, because they now believe it.
Exactly. And these sentences show this weird relationship between truth and belief.
Mm.
And they're a challenge for any logic that tries to model them. They force us to think about the dynamics of belief in a way static logics can't.
Right. It really gets at the heart of self-reference and how our beliefs can impact the truth of statements about those beliefs.
Exactly.
Now, PL isn't all intuition. It's a formal system.
Right.
We use Kripke models
All right.
to give it a precise meaning.
Yes. And for a philosopher familiar with possible worlds, this should be familiar territory.
It should.
Kripke models are these abstract structures that represent all the possible ways the world could be,
Okay.
along with relations that tell us for each agent which worlds they consider possible.
Right.
These accessibility relations encode their uncertainty.
And the truth condition for the public announcement modality, FG, is defined in terms of an updated model.
Right, which is basically the original model M
Right.
with all the worlds where F is false removed.
So the announcement acts as a sieve, getting rid of the incompatible possibilities.
Yeah, a logical sieve. I like that.
Now, when we talk about applying PL to existing logics, you mentioned PL-friendly theories.
Right.
What makes a logic PL-friendly?
So a few things. First, it needs to be a normal multimodal logic, which means it has the usual propositional logic stuff plus modal operators for each agent, like AF, meaning agent A knows F.
Okay.
Second, it should have a class of Kripke models where the logic is both sound and complete.
Right, meaning everything provable is true and everything true is provable.
Exactly. And third, and this is key, we need a way to restrict the public announcements so that if we start with a model in our friendly class and make an announcement from this restricted set,
Mm-hmm.
and assuming the announcement is true somewhere, the resulting updated model is still in that same friendly class.
So it preserves the structure.
Exactly. And make sure the properties we care about in our base logic stay true, even after an announcement.
And you mentioned some examples like KD45 for belief and
Yeah.
S5 for knowledge.
Yeah, those are classics, and they are PAL-friendly properties like reflexivity. If you know something, it's true in all the worlds you consider.
Mm-hmm.
Transitivity, if you know P, and P implies Q, then you know Q.
Right.
Euclideanness, if you don't know something, you know that you don't know it. These are all preserved under public announcements.
They are, but seriality,
Mhm.
which for beliefs means you don't believe a contradiction, that's not always preserved, is it?
No, it's not. And that leads to some interesting philosophical questions when we want to analyze announcements in logics that require beliefs to be consistent.
It does. So we have the basic structure of Peel. Now, how do we reason within it? How do we derive new conclusions? You mentioned an axiomatic theory, also called Peel.
Right. And for a philosopher, that just means a set of axioms and rules of inference.
Okay.
So the axiomatic theory takes the axioms and rules of the underlying Peel-friendly logic
Okay.
and adds these special axioms called reduction axioms that govern the public announcement modality.
Okay.
These reduction axioms are really the key. They let us rewrite any formula with an announcement modality into an equivalent one that's simpler, and eventually we get rid of the announcement modality altogether.
So you're simplifying it step by step.
Exactly.
And those reduction axioms really reveal something about public information, don't they?
They do.
Like the first one, FP left, right, taro. It tells us that after announcing F effect P will be true if and only if F being true already implied P was true before.
It's like the announcement retroactively checks for consistency.
Yeah. And the other axioms handle more complex structures like conjunctions and negations and how knowledge works after an announcement.
Right, like FAG, left, right, FG, it says that agent A knows G after an announcement of F, if and only if being true meant that agent already knew that G would be true after the announcement.
Okay.
So it breaks down the impact on their knowledge.
And you gave an example of a reduction sequence for... It's amazing how you can peel away the announcement modality like that.
Yeah, it's very systematic, and that's what the Pale reduction theorem formalizes. It says that everything we can say in public announcement logic,
At least without common knowledge.
right, at least without common knowledge, can be translated back into the basic modal logic without announcements, which is really powerful because we can use all our existing knowledge and proof techniques from the base logic to analyze this more complex logic with updates.
And that reduction theorem is key to proving completeness, isn't it?
It is. If we can always get rid of announcements and our base logic is complete, then PL must be complete too.
Because everything can be reduced to something we know is complete.
Right. And the Kiel soundness and completeness theorem formally proves that our system captures all the logical consequences of public announcements on the appropriate Kripke models.
So the system is sound and complete, which is what we want.
Exactly.
Now, there was also that scheme you mentioned. FGH, left, right, arrow, fanned, FGH. It seems to say something about what happens when we have multiple announcements in a row.
Yes. This scheme shows that announcing F and then G is the same as making one combined announcement, F is true, and after announcing F, G is true.
So we can collapse a series of announcements into a single one.
Right, which can simplify things a lot.
You also mentioned some complexity results about P&L. It seems like figuring out if a PL formula could be true. The satisfiability problem can be computationally hard, especially with multiple agents and logics like S5.
That's true. Satisfiability for a single agent S5PAL is NP complete, which is already tough.
Oh, okay.
But for multi-agent S5PAL, it becomes PS space complete, which is even harder.
Wow.
But model checking, which is checking if a formula is true in a specific model, that's easier. It's in P.
So there are different levels of complexity depending on what we're trying to do.
Right, and these complexity results help us understand the limits of what we can automatically reason about.
They do. So PL gives us a good foundation for public announcements, but what about when things are more complex? When communication isn't so open? What if someone gets information privately?
Right, then we need something more general, and that's where action models come in.
Okay.
They let us describe a much wider range of situations.
Right, like secret messages or whispers.
Exactly. Think of them as blueprints for how knowledge changes due to communication, which can be much more subtle than just public broadcasts.
And the example you gave, the completely private announcement, really illustrated that.
Yeah.
It's not just what's said, but who knows what and who considers what possible afterwards.
Right. The knowledge states of the agents can really diverge.
They can, like in your example, Agent A learns P while everyone else thinks nothing happened.
And that's exactly how we want to model a private announcement.
So formally, an action model, AERAS, has a set of events, E, that could happen.
Right. Like different communicative acts.
For each agent, there's an accessibility relation on those events representing what they consider possible.
Yeah, what they think might have happened.
And each event has a precondition.
Yeah.
Which is basically what's announced or learned if that event happens.
And the key is that the actual event might be different from what others believe happened.
Right, so it captures those private or partially observable communications.
Exactly.
And then we have the product update, which is how these action models change our Kripke models of the world.
Yes. Given a Kripke model M for the initial situation and an action model A for the communication, the product update, gives us a new model that reflects the knowledge after the action.
Okay.
The worlds in M are pairs of a world from M and an event from A. But only if the event's precondition was true in the original world.
Right. So it has to be consistent.
The accessibility relation between two such pairs, say V1F1 and V2F2, for an agent holds if there was already an accessibility relation between the original worlds V1 and V2 in M, and also an accessibility relation between the events F1 and F2 in the action model from that agent's perspective.
So it combines the uncertainty about the world with the uncertainty about the communication.
Precisely, and the truth values in the new world event pairs are just inherited from the original world.
Okay, and the example you gave with the private announcement applied to a model where no one knows P really showed how this works.
Yeah.
Agent A ends up knowing P, while Agent B is still uncertain.
Just as it should be with a private communication.
And you pointed out the similarities between action models and Kripke models. They're both these graphs that represent uncertainty.
Right, but Kripke models are about uncertainty of the world. And action models are about uncertainty of the communication itself.
So 2 levels of uncertainty.
Exactly.
You also gave some other cool examples of action models.
Did I?
Like public announcements can be seen as action models with just one event that everyone knows happened.
Right, that makes sense.
Then there's the semi-private announcement where the recipient knows the message, but others are still unsure, leading to different updates in their knowledge, and the misleading private announcement where one agent learns something true, but others are tricked into believing something false.
That's a really interesting one.
It shows how action models can even represent deception.
Yeah, which is a really powerful concept.
So action models can capture a lot more than just simple public announcements.
They really can.
And just like we have PL for public announcements, action models lead to their own logic. Epistemic action logic, or EA.
Right.
Which lets us reason formally about the effects of these action models.
And it has a new modality, AEEF, meaning after action A with event E, formula F will be true.
And like in PL, we have the notion of when an event in an action model is possible or executable.
Right. An event is executable if its precondition is true.
An action model is executable if at least one event is executable somewhere.
Okay.
We also have an action model closure theorem, which ensures that if our initial Kripke models and action models have certain properties like reflexivity, transitivity, Euclideanness,
The good properties for knowledge and belief.
then the models after the product update will still have those properties.
So those key properties are preserved.
They are. And EL also has reduction axioms, just like PL.
It does.
They let us transform formulas with action model modalities into equivalent ones without them.
Right. So we can reason within the basic modal logic again.
And this is captured by the EL reduction theorem, which is essential for proving the completeness of EL.
It's a very important result. It shows that EL can be grounded in the simpler logic.
And this leads to the soundness and completeness theorem, which tells us that our logical system and its meaning are perfectly aligned.
Just like we want.
Exactly.
So EL is a really robust framework for reasoning about all sorts of knowledge changes.
It is going beyond those basic public announcements.
Much more general.
You also mentioned action model composition, which sounds like a way to combine epistemic actions.
Yes. The composition of 2 action models, A and B, written, A circ B, is a new action model whose events are pairs of events from A and B.
Oh.
And the accessibility relations and preconditions for these combined events capture the idea of doing action A and then B.
So it's a sequence of actions.
Right. And the composition theorem tells us that applying A then B is logically the same as applying the combined action A circ B in one go.
So it simplifies reasoning about multiple actions.
It does.
And lastly, about action models. You mentioned some things about their complexity.
Oh.
It seems like EL is even harder to reason with than pollen, especially figuring out if a formula could be true.
That's right. Satisfiability in EL is next psi time complete, which is worse than psi space.
Okay.
But model checking is still in PS space.
So it's still doable in specific models.
It is.
But the general case is harder, which reflects the power of EL to handle more complex actions.
Exactly.
Okay, so we've seen how DEL handles knowledge updates through public announcements and action models, but what happens when new information contradicts what we already believe? That seems tricky.
Yeah, you're right. The frameworks we've talked about so far can run into problems there.
They can.
Like if someone strongly believes P and then we publicly announce L or not,
The opposite of P.
standard DEL can lead to trivialization.
What does that mean?
It means the agent's beliefs could become inconsistent. They might end up believing everything, even contradictions.
Oh, wow.
This happens because DEL often updates by removing impossible worlds.
Right.
But if the announcement contradicts a core belief, all their worlds might get removed.
So they have no beliefs left.
Basically, which is logically weird and not how real people revise their beliefs.
It's not. So we need a better way to handle belief change, a way that can deal with inconsistencies.
We do, and that's where belief revision comes in.
Okay, so belief revision is all about how we should rationally update our beliefs when we get new information that might clash with what we already believe.
Exactly, and there are these influential AGM postulates.
Named after some smart folks, I'm guessing.
Alcaron, Gardenfors, and Mackinson,
Okay.
which are like guidelines for rational belief revision.
They are like the success postulate, which says, after revising with F, you should believe F.
Right. It seems reasonable.
It does. So how does DEL fit in with all this?
Well, DEL approaches to belief change build on those ideas, but take them further.
Way.
First, DEL can handle not just beliefs about the world, but also beliefs about beliefs.
Okay, those higher order beliefs.
Right. Second, it works for multiple agents, so we can see how one agent's revision affects others. And most importantly, DEL can be more nuanced about the new information itself.
Like we might trust some sources more than others.
Exactly. Or we might tentatively accept something but still have doubts.
So it's not all or nothing. You also talked about static and dynamic belief change in DEL. What's the difference?
So static belief change is like a hypothetical thing. It's what an agent would believe if they accepted some information.
Okay.
But their actual beliefs in the model don't change.
It's like a thought experiment.
Yeah, but dynamic belief change is when we actually update the agent's beliefs in the model.
Okay.
And that can change which worlds they see as most plausible and therefore what they believe.
So their beliefs actually change within the system.
They do, and the more sentence example really shows this.
Yeah.
When an agent believes OP is true, but I don't believe it, that very act makes the second part false.
Right, because they now believe it.
Exactly. So belief change can change the truth of the thing that caused the change.
It's a mind bender.
It is, and it shows why those AGM postulates don't always hold, especially with self-referential stuff.
So to model these more complex beliefs and how they change, DEL uses something called plausibility models.
Yes, plausibility models.
Which add a new element, a plausibility ordering between worlds.
Right. Written as DECA, where W1 DECA W2 means agent A considers W1 at least as plausible as W2.
So it's not just what's possible, but also how likely each possibility seems.
Exactly. It captures the agent's degrees of belief.
And we have related notions like strict plausibility, W1, W2, where W1 is more plausible than W2.
Right.
And converse plausibility and equiplausibility.
All derived from that basic plausibility relation.
And these plausibility models have some interesting properties like local connectedness.
Yeah, local connectedness means that in all the worlds an agent considers their connected component, they always have an opinion about which of any two worlds is more plausible.
So they're never completely indifferent.
Not within their connected component, they always have a preference.
And another important property is converse well-foundedness.
Right, which guarantees that in any non-empty set of worlds, there's always a most plausible one.
Okay.
So we don't have these infinite chains of decreasing plausibility, and the notion of most plausible is well-defined.
So a plausibility model gives us a richer picture of an agent's state of mind.
It does. It includes not just what they think is possible, but also how plausible they find each possibility.
Now, how do we define things like knowledge and belief within this framework?
So we can define different modal operators that capture different notions, like KLAF for agent A has conclusive information that F is true.
Okay.
So F is true in all the worlds A considers possible.
So it's a strong, indefeasible belief.
Right, like traditional knowledge in S5.
And then there's box F for agent A defeasibly knows F.
Yeah.
Which means F is true in all worlds, no more plausible than the actual world. So it's a weaker belief that can be overturned.
It's like a safe belief as long as no better counter evidence comes up.
Okay, and then there's informational consistency and conditional belief.
Right. Conditional belief means agent A believes F given G.
Okay.
And the cool thing is that this is true if and only if holds in all the most plausible G worlds that A still considers possible.
So it connects to the idea of hypothetically revising your beliefs with G and seeing if you then believe F.
Exactly. It's a nice link to static belief revision.
An unconditional belief is just conditional belief with the always true condition.
Right. So an agent believes F unconditionally if F is true in all their most plausible worlds.
These definitions give us a formal way to represent different kinds of beliefs and plausibility models.
They do, and the K-box soundness and completeness theorem tells us that our logic for these modalities works correctly with these models.
So we have a sound and complete system for static beliefs.
And we also have conditional doxastic logics that take conditional belief as the starting point.
But how do we handle dynamic belief change when new information comes in?
That's where plausibility action models come in. They're like action models, but with an added plausibility relation on the events.
So now we not only know which events are possible, but also which ones are more plausible.
Exactly. And that's crucial for modeling how we weigh different sources of information.
We do. Some sources are more reliable than others.
Right. And the way these models change our plausibility models is through the action priority update.
Which prioritizes updates based on the plausibility of the action itself.
Exactly. So when plausibility action model A happens with event E, and we apply it to model M, we get a new model MA.
Right.
The worlds in the MA are, again, pairs of worlds and events. But the new plausibility relation prioritizes pairs that came from more plausible events.
Okay.
If two pairs came from events where agent A thought one was strictly more plausible,
Uh-huh.
and the original worlds were indistinguishable for them,
Okay.
then in the new model, the pair from the more plausible event is no less plausible regardless of their original relation.
So the action's plausibility overrides the world's plausibility.
It can, and if the events were equally plausible, the original relation between the worlds is kept.
So it's a subtle interplay.
It is, and this mechanism allows belief revision to be sensitive to the source of information.
Right, we don't just accept everything equally.
No, we weigh the evidence.
So more plausible information has a bigger impact on our beliefs.
Exactly. That's the core of dynamic belief change in this framework.
And we have a logic for this too, right? Action Priority Update Logic, or APL.
Yes. APL extends the logic for plausibility models, KBOX, with modalities for applying plausibility action models, A, E, E, F.
Meaning after action A with event EF is true.
Right.
And you give some good examples like the revisable public announcement, where we can come to believe the announcement but still leave open the possibility it might be false.
Yeah, it's more realistic that way.
It is. We rarely have absolute certainty.
And there's the private announcement to a group where different agents revise their beliefs differently depending on who heard what.
And you also mentioned how lexicographic upgrade and conservative upgrade from belief revision theory
Those classic upgrade operations.
can be represented using specific plausibility action models.
They can, which shows the flexibility of this approach.
So APUL can model a whole range of belief revision scenarios.
It really can.
And like the other logics, APUL has an axiomatic theory with reduction axioms and an APUL reduction theorem,
It does.
which lets us simplify formulas with action model modalities back into KBOX, the logic for plausibility models.
Right, so we can connect the dynamic and static aspects.
And those reduction axioms really capture the heart of how plausibility is updated.
They do, especially the fourth and fifth ones you mentioned. They really reflect the action priority update.
And you briefly mentioned composing plausibility action models so we can analyze sequences of belief revisions too.
Yes, we can extend the analysis to multiple updates over time.
So DEL can handle not just single updates, but whole chains of belief change.
It can't. It's a really powerful framework.
It is. This deep dive into DEL has been really eye-opening.
I'm glad.
We've gone from the basics of PL and action models to plausibility models in APL.
A lot of ground covered.
It's amazing how logic can model the dynamic nature of our beliefs like that.
It is, and it's a very active area of research, too.
But the story doesn't end there, does it?
No, it doesn't.
You mentioned research on evidence and justified belief, which seems very relevant to formal epistemology.
Absolutely. Researchers are working on extending DEL to include evidence explicitly.
Okay.
Drawing on ideas from awareness logics, justification logic, and using things like modal neighborhood models
Wow.
to analyze what makes evidence good and how it leads to justified belief.
So DEL is becoming even more powerful for formal epistemologists.
It is. It's helping us tackle those age-old questions about justification and evidence.
You also mentioned connections to temporal logic, which makes sense given how dynamic DEL is.
Right. The before-after nature of action model suggests a link to time.
Mm-hmm.
And some researchers are explicitly using temporal frameworks to analyze how knowledge and belief evolve over time.
Okay, so DEL might not always have explicit temporal operators,
Not in the standard languages.
but the ideas are there.
They are.
And you also highlighted the connections between DEL and mainstream epistemology,
Yeah, DEL can actually help us analyze traditional philosophical problems.
which is really exciting for us philosophers.
It is DEL can formalize different conceptions of knowledge.
Okay.
Like Almans and Stalnakers, it can analyze Gettier problems.
Those tricky cases where justified true belief isn't knowledge.
Exactly, and even Fitch's paradox of knowability has been explored using DEL.
So these formal tools can shed new light on those classic questions.
They can, and it shows how fruitful it can be to combine formal methods with philosophy.
It really does. So we've covered a lot today, from PL and action models to plausibility models and APUL.